Welcome on everybody, welcome. It's I'm getting a little bit of a late start. I apologize. I've been kind of getting things together here and stuff, but I am here now, my friends, and I'm going to ask you for forgiveness and to indulge me for a bit here because this week I am I'm just on a programming kick this week. I just really am. I didn't plan on this week being just a coding week, but I'm feeling more motivation than I've felt in a long time. And it's just like, because I had every intention of just playing a game tonight, and I was like, I just kept thinking about it, like, I'm not going to focus on the game. Like, I have games to play, but I'm just not going to end up focusing on them. Instead, I'm going to be thinking the whole time about this code here. So I figured just indulge the the inner beast, as it were, and let's just jump back in and do some more stuff. We'll see. What's got me bothered? So I've gotten through all of chapter 16 today off camera. We had started it last night. I'm now through all the changes, I believe. But I've got a bit of a conundrum. So let's get this guy up here. So the top here is the book's example code. And when I run that, okay, this is the scene we get. You can see more prominently the tree and the shadows that's casting. Also, you know, these poles are casting shadows, and everything looks pretty darn clean. If I cycle the overhead light a little bit, you can see everything's looking really, really smooth and really clean there. Okay. Now, here is my attempt. And, yeah. Like, I'm getting shadows, but they've got jagged edges on them. And the tree itself is not casting any shadows, although it kind of does sometimes when it feels like it. Like some of the leaves are kind of casting a little bit of a shadow, and I wish I could zoom in, but I can't because I haven't fixed the keyboard inputs and stuff yet. And all the shadows over here, you can see they're kind of flickering. Like the shadows are just sort of not quite right. There's a lot of flicker going on there, which there was not flicker in in the books thing. So something's up. And I thought, well, since I'm getting a lot of jagged edges, maybe the FXAA is not getting applied properly. Maybe that's kind of out of order. Maybe I missed something when I was going through and trying to see all the code that has changed and everything. Let's bring up the comparison here. Like I went through the shaders, and I'm pretty sure I've got all the shaders. Like there wasn't that many changes, but you know, there were a couple. And I'm pretty sure I've captured all those changes. I mean, the shaders themselves are hard to grok. So what I could do, let's rule out the shaders first, which I think is relatively a good place to start anyway. So we've got, so the lights fragment shader. So what I'm gonna do is I'm gonna copy this over. Or yeah, I'm gonna copy it over because this is the easiest way that I can. The comparison that IntelliJ does is a lot nicer than compare. So I'm going to do this. I'm going to paste it in here. And I'm just going to go look at this and compare it to this, and we'll see what changes there are. Let me bring this up full screen so I can see it. Oh, I compared the wrong file. I'm like, that's way too many changes. No, it's lighting fragment shader and lighting fragment shader. Here we go. Like, man, I really messed that one up. Where's the compare files? Here we go. All right, so it's just spacing that's different there. It looks like so that's not a big deal. There's an extra space on, so this is mine on the right and this is theirs on the left. So there's an extra, I have an extra space in there. I've renamed this, but I refer to it in that name, so it shouldn't be that big a deal. Position sampler, another name. Just kind of expanded on. Cascade shadows. Some capitalization and a comment. I added braces around this even though it's not necessary. I just did it out of habit. More capitalization in comments, but otherwise everything else is the same. So I have Cascade capital S shadows. That should be consistent. Yeah, that is consistent. Okay. That's fine. Vision view matrix. Some spacing there. Comment. More variable naming, but they're consistent. Position, cascade shadows. More spacing. Variable names, and then spacing and variable names. But otherwise, everything else is the same. All right, so that, as far as I can tell, that shader is fine. So then, what's the next one that changed? So we have 3 new ones: shadow fragment, shadow geometry, and shadow vertex. So these should, let's just compare these. I wonder if I can compare across things. I doubt I can, but let's just see. Shadow. No, I didn't think so. I just thought I would try. So let's copy these new ones over. And then I can compare them. So look at the shadow fragment shaders first. That's the wrong. Why did I pick swap chain? Here it is, shadow fragment shader. Compare. All right, more variable names. Variable names. So mine is on the left, and theirs is on the right. Variable names and variable names. Okay, so those should be fine. Shadow geometry shader. So variables, spacing, variable names, variable name. More variable names, so that's fine. And then the vertex shaders here. Okay, mine is on the left again. Shape material index, texture coordinates, material index. Okay, it's just variable names. All right, so it looks like to me the shaders are fine, which I suppose tracks. So the question now is, did I align all the variables correctly with the uniforms and the shaders? That's one thing. I'm going to kind of lean towards the I might have. I probably did. Because things are relatively working, but they are really jaggy, so I could have something misaligned there. And something misaligned with memory as well, in the memory buffers. So I'll have to look at that, and also have to look to see if I just kind of plain old missed something that changed from one version to the other. So I think, first of all, I want to control, like, I have the camera control set up with the, or I did have the, I did have it set up where we can move the directional light, with the keyboard, but it goes way too fast, so I need to get it so that this works a little bit better. So what I'm going to do, I'm going to go into the lighting input callback here. And we don't have a point light anymore, so I'm going to get rid of that stuff related to the point light. With directional light at 270, there was also a small change to this down here where it was like, I think they changed it to from 180 to like 240 and then 300, I think. So let's do 240. 240 and 300. 300. Let's see, update directional light. Which means I can get rid of the point light stuff. We don't need that anymore. directional light there. What I need to do, what I want to do, and this is just for the keyboard's callbacks in general, is I need to slow them down a little bit. Even if they move at, you know, a consistent velocity, I need them to kind of move at a point where I can manage it. So what I'm gonna try to do here, so we pass a delta time milliseconds in, but that is input timer get instance delta. Yeah, okay. So I created like an input timer to try to do this, and it's not quite working. Well, it's not quite working because I don't think I'm actually doing it. So I do a tick, which is the checkpoint. What do I call this? Okay. I was doing this light timer, which I don't need anymore because that was for well, that was actually for this, but yeah, I don't need that in here anymore. So I'm not going to be calling this stuff in here. Let's get rid of some things. So I did do like this light timer diff thing. Get rid of all of that. Where's this, wait a minute. Where that came from. Let's back to void. The parameters to it. I'll get rid of this down here because it's redundant at this point. And here I need just the directional lights. There we go. I'm going to add that back into the keyboard handler. All right. And then we've got, so I've got an input timer tick that happens. All right. Also, I don't know if I need this thread sleeve. I put it in there at some point for some reason. I don't think I actually need it. Because should render is based on a FPS frame. Yeah, so I don't think I actually need this. I'm just gonna kind of get rid of that in case that's creating some sort of stutter, which is entirely possible it is. The directional light, I don't need that anymore. Angle anymore. Alright. Let's see what we got here. So, got an input timer that's going. So I did timer tick. So then what I want to do is that's a whatchamajigget, that's a singleton. Right? Did I made that a singleton, I think. Yes, I did. So what I would like to do in here is say, move. I will say if press keys not null, and I'm going to say let's do long delta input timer. And calling that, I believe, resets it, right? No, it doesn't. Okay. That's fine. That's good. Okay. So delta input timer, and then I'm going to say Boolean do increment is the delta input timer is greater than let's see, we'll do 250 milliseconds for right now. Wait, is this in milliseconds or nanotime? This is in nanotime, so that would be 2500. I think so. Yeah. No, 1,000. I think that's 25,000. How many nanoseconds in a millisecond? There are 1 million nanoseconds in a millisecond. Oh, I was off by quite a factor there. So we want so I think so a million. So it'd be, let's see, 1, 2, 3. So 25 million would be 25 milliseconds. Yeah, 25 million would be 25 milliseconds. I want 250, so it should be 250 million. Wait, 1, 2, 3. I think I have too many. 1, 2, 3. 1, 2, 3. Yeah, no, 250 million. Okay. We'll see. We'll see. So if that is greater than that, then do increment is true. So I'll say if press keys does not equal null, and do increments. Oops, press keys does not equal null. And do increments. And then input timer instance tick. I know this is not the greatest way to do this, but because it's gonna, every input's gonna affect the next input down, but this is it's good enough for what I'm trying to do. Hopefully, we'll see. We'll see if it works out in my favor or not. All right, so really quick, let's see if this does anything. I don't know if it's actually moving or not. I can't really tell if it's actually doing anything. Let's reduce this by a couple factors here. I don't know if it's working. Let's say, oh, I bet you I'm already running into a problem here. I guess perform action is already pulling the delta in, so I don't have to do it myself. That might be... yeah, okay. I didn't realize I was doing that. Did not realize I was doing that at all. But that being said, where's my thing at here? What else is using that? Mouse. I don't think I'm actually doing it in the mouse callback though for the camera. I guess technically I am because let's see. Oh, I'm just printing it out. I'm not doing anything with it. Okay. Or, well, I would be logging it if I was at trace level, but I'm not. Okay. That's fine. That's fine. But I want to say... let's do something. Let's put a logger debug. Okay. Actually put that out here. Directional light angle. Plus angle increments. Okay. So private static panel logger. Okay. Cool. And then I can only see if it's printing anything out in the log. Let's delete this log so I don't get confused with what's already in there. I'm just holding down the key right now. And we'll see if that fired off. Oh, there is something going on here. What? So I am getting something in the log. Should be looking at. So resource range, base array layer count 3 is 3, which is greater than the array layers of the image when it was created 1. Okay, so maybe that's hinting at what I've missed. I guess I should have looked in the log in the first place. But anyway, I'm not seeing any. I'm not seeing any keyboard callback there. Well, that would explain why it's not moving. All I care about is the left and right keys right now, so I can get rid of these other ones. So... just for the sake of argument. Make sure that's even working. Okay. Let's see. That is working. $4,000. What do I have it set for? So it's getting reset well before it makes it to this number. So it must be, I must have been right with like 25,000, right? Or let's just try 25,000. Maybe that's the whole problem right there. Okay, now it's definitely moving. At least a little bit. I think that timer's getting reset a couple times. But yeah, okay, so that it's moving a little bit more now. It's just, I think that timer's getting reset by something else. I should have separate timers for things, but yeah. 71, so it is changing the angle periodically there. Yeah. Okay. But what I'm more interested in is this other error I'm getting. Create image view. Layer count. Base array layer. Layer count is 3 which is greater than the array layers of image that was created. See, here's the problem. So it's like after it's creating the pipeline, but then again, I don't know which. I don't know where. Like it tells me things, but then it doesn't tell me where those things are happening. Because it always comes back from render instance. So I gotta see if there's a way that I can dig in and find out like where are these errors, like the source of the errors that are being generated. So layer count. Layer count of 3. So let's see where I can find layer count of 3 in this mess here. Layer count. Layers. If layers is greater than 1. Then we set the view type to VK image view type 2D array. This is saying that the view type is not being set to VK image view type 2D array in a certain situation where we're setting the layer count greater than 1. Okay. And here they capture if layers is greater than 1, they set this view type. So layers. There's 1 there. There's 1 there. Hey, Outlaw. Welcome on in. Yep, music is pretty kicking today. Here's 1. These are all layers 1. I am doing good. I am doing good. I am So this is where it would be set to 3, is wherever we do shadow map cascade count. So it's got to be in the new shadow render stuff. Right, because that's the only place. Everywhere else it's set to 1. So I know I went through and set everything to 1. So then that's the question here. Did I miss? I must have missed a line of code where that's set. So let's do. What is that? Shadow. Shadow utils here. No. What is that? What's in scene? I imagine I put it in Vulkan scene. Yeah, shadow map cascade counts. So wait a minute. Where is the... It's gotta be here, right? Yeah, so there's attachment. Init color attachments. Init depth attachment. And this is in shadow renderer. Create color attachment. Create depth attachment. So for both of those, set to 3. So why is that? Layers greater than 0. Array layers. Where the hell does array layers come into play? Array layers is defaults to 1. That's literally the only usage of it. Is it being set. That's probably why I didn't bother with it. And then layer count layers. If layers is greater than 1, setting this. View type. Now that view type has no usages? That's not right. Be right. So view type. Oh, when you create an image view. Oh, it just pulls it directly. That's why it didn't show up there. Okay. When you create an image view, it pulls the view type. So when I do a Vulkan image view, Image view data. Type, wait, why did I set that to that? Oh, that's what they have here. Image view type 2D. Okay. So, I have that set to that. So then, I'm setting data to image data. And I'm getting the view type. So why is that? BK image view type 2D. 2D or 2D array, which is what it is set to by default. So that data is not getting set in attachment. Layers is greater than 1. I'm clearly setting it here though. See if this gets hit. Yeah, it most certainly does. So I just did that. What does the log look like? So it's just printing out that it's not correct. It's 3, which is greater than array layers of the image when it was created. Is not BK remaining array layers. Image is not a 3D image create with. So view type is not 2D or 2D array. Must be non-zero, must be less than or equal to the arrays when creating the image. Oh, okay. So it's when the image was created, it's saying it wasn't created with those, with that in there. Okay, okay. So that means, let's stop this here. When the image was created, so this Vulkan image here, right? Vulkan image, layer count. Oh, array layers are set to 1. I probably missed this then in image here. The hell is it at? Sorry if I'm ignoring chat for a moment here. I'm deep in debugging here. Image view data. Image view. Where's the image created? So here's image with image data. Okay, image data. Ah, there it is. Image data array layers. Which is what they're setting? Question mark? Layers is greater than 0, set array layers to layers. That's what it's doing. Okay. That's what's going on. So they're just saying, that's why this is here, because they're setting array layers to that, which I didn't pick up on. I didn't pick up on that this is different than what they were doing here. that's what I missed. Okay. So, array layers. So then for mine, I have layer count. Layer count. So array layers should be set to layer count always now. That's always going to be set at this point because in the constructor. And then this. So height. So that's just set to 1 there, which is correct. And then the other one is set to layers. Yes. Okay. So now let's run this. Now I have now the tree is correct, but I'm still getting really jagged edges though. So I feel like the FXAA is not kicking in there. Let me see what theirs looks like again. Yeah, see how smooth theirs is? I mean, their edges, I mean, there's a little bit of raggedy edges there, but it's not as ragged as my edges, I don't think. Maybe I'm, like over there it looks pretty ragged. But see, these poles that are up top here come out really smooth. Like, see how smooth those are there? Mine definitely are not. Let me look again. Let's run this. Yeah, see how they've got jagged edges on them? They're definitely more jagged, especially over here where it's off the pot and stuff. Okay. So I feel like the FXAA is not running here. You see, are there any other errors from the validation layers in here? Like it, but we're exceeded the file size there. Let's try that again. So we got that. What does that say here? Stop printing those out. Yeah, I'm filling up the log with stuff here. Where's my thing at? The input callback. Let's make this a little bit shorter and the increment the way it is there. And let's get rid of that because it's definitely working. Oh, you know what? I'm resetting it here. That would be part of the problem, I would say. Put that back like that. Let's see if this is a little bit smoother, at least with the movement. No, not really. Let me take another 0 back off of there. Let's try it now. A little bit better. Still, I wonder why that's hopping up and down like that, though. Yeah, see how, like, you can see on the tree leaves there, like, how jagged they are? Either I'm the performance is not good. But see, even when it stops, it's jagged. So, and where it was smooth with the other one. So I think I'm missing something here. But yeah, to answer your question earlier, Outlaw, I'm doing okay. I'm doing good. No complaints. I am I'm stuck on a coding kick this week. I was saying when I started up the stream that I had every intention of playing a game tonight, but I knew I would be distracted while playing the game, like, because this stuff is just like occupying all of my brain right now. Like, I'm more motivated to do this than I've been in a long time. And so I'm kind of like, either I don't stream at all, or I indulge and just kind of let the worm wiggle its way through my brain until I go back to work and I'm too tired to do this stuff every night. So we'll see. That's where I'm at with that. Wonder. Okay. So let me think here. So the other thing is in the, let's see, the user, was it the Vulkan renderer? So when we call, so there's now a shadow renderer. All right, and then that's the cleanup for it. Where's the, so we do a shadow renderer, load materials. Right. And then in render, so we take, but here's the thing though. Yeah, we take the scene renderer and then oh, wait a minute. The shadow renderer, I guess technically is adding entities to the scene, so it doesn't need a previous thing. So if I go to their renderer and go to their render method, yeah, because it just adds more to the scene, right? It adds the shadows to the scene. And then the light renderer takes the scenes attachments and the shadow renders attachments. The cascade shadows. And then the post-processing renderer still grabs the product of the light renderer, which is correct. But light render. Shadow attachments, cascade shadows. Shadow attachment's not used again. Now the shadow matrix was added in as the descriptor 2, but that I've definitely changed right with the in the lighting fragment shader. Set 2 is the cascade shadows, yeah, and then set 3 is now the scene info. Oops, let's go back here. Yeah, 2 is shadow matrices, 3 is the scene render. Yes. 1 is the lights, and 0 is that. One is the lights, 2 is that, 3 is that, and then 0 is sampler. Okay. But maybe I did something like that. Yeah. Yeah, that's the thing. I was like, I was like, you know what? If I play a game tonight, I'm not going to be focused on it. So I should just, it wouldn't be any real fun to watch, you know? So that's kind of why I was like, let me just work on the coding, because that's what's occupying my brain. I wonder if update cascade shadow matrices. So we've got cascade data, data list, get offset data buff. So it's 0. Buffer map, shadow matrices, current frame, map memory, buffer map, data buffer, I forget request size, offset 0. So offset 0, puts projection view matrix into data buffer. And then it offsets 0 plus matrix 4x4 size, which is 64. Alright. Make sure it's the same over here. 64. Put the split distance. And then offset plus equals another 64 plus vector size. So it's taking 0 plus equals this, and then the vector 4 size, which is the size of this distance, and adding that to the offset. Did I do that right? Yes. And then I'm doing cascade data, get projection view matrix. Putting that in there. So, okay. Cascades, and then unmap the buffer at the end. I think that's all correct. So, I wonder if they mention anything in here about like getting jagged edges on things. See shadow debug, see cascade splits. Polygon mode. Fill call mode none. Wait a minute. Pipeline rasterization state create info. Did they change? I know they added the depth clamp enable. Is that the only thing they changed there? What is this? The pipeline? Yeah, it's literally the only thing they've changed. Let me check it anyway. So depth clamp enable is there, and then Polygon node full. So, I want this one. I think I have it in here. Yeah, so what was that? Rasterization state create info. Okay. Polygon mode fill, call mode none. Call mode none, front face clockwise, depth clamp. 1. It's line width, okay. Depth clamp. This is only called in one place, so that should be set to true. I guess I can. Let's debug to this part here and just make sure that is set to true. Info. No. Depth clamp is set to false. Huh. So maybe that's what's causing it. Oh, now it's true. Where am I? Oh, because I'm in a pipe. Right, because this pipeline's called a couple different ways. Sunday. False, 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 false. Yeah, at certain angles it gets really, really bad. Which is very weird to me. That's happening there. Like when I get there and I go to a certain angle, I don't get the same thing, do I? No, look how smooth, like no matter how I tilt the camera, it's buttery smooth. So what the freak did I do? I wonder if this all comes back to that I wonder if this all comes back to that change that I made. I mean, I could try, let's, just for the sake of argument, shadow utils. So I moved this, oh, this is the wrong, that's the wrong. I'm like, this doesn't look like my thing. Shadow utils. So I had moved this here outside the loop, and it really shouldn't make a difference, but I'm going to, just for the sake of argument, let's comment this out and take a copy of this and put it inside the loop again. See what happens. No, it's still messed up. I was like, there's no way that that's doing it. And I was right. Okay. Okay, so it's not that. We know my shaders are correct. Did I mess something up in this calculation while I was getting creative here? This is in Shadow Renderer. So shadow render, render. All right, update cascade shadows, current frame scene, frame scene. So what I could do, what would be the best way for me to look at this? Last split distance. Can we see if the last split distance, the three of them are coming out the same way? So let's see. Let's debug this. All right, so last split distance is what? 0.0516. And then the next one is 0.230. And then 1.0. Okay. So then for mine, it is 0.068. That's already different, but that could be just, that could be correct. 0.277. Because the lighting might be at a different angle. And then 1.0, which was the same. I mean, they're a little bit off, but they're not off by that much. So I can't imagine that that's... Huh. Huh. What's funny is that, like, at certain angles it looks fine. It gets worse as you get to a different angle there. I don't know. I mean, technically it's working, but I don't know why. I don't know why it looks so crappy. Maybe it does. Maybe it's coming down to like a performance thing. Maybe. Maybe my version of the engine's just not running fast enough. I wonder, just out of curiosity, their engine Fig. They have their FXAA here. So they have the default value is true. I wonder if they left that. Yeah, they still got it set to true. Huh. Huh. Log shaders, field of view 60, 30 updates per second. VSync, shader recompilation. You don't have a thing there for... You didn't put properties in for the for these, so they're defaulting at the 2048 and false for the debug, which is the same that I'm setting them for. Very interesting. Yeah, I don't know. See, it's things like this where I'm not quite sure where to look to see what's going on, which is, I think, is probably the more frustrating aspect of it. Is that it's like an endurance race, right? You put all this effort into writing all the code, and then it kind of works, but it kind of doesn't. What if it says Minzy is redundant on this one? Yeah, it does. Okay. I wonder, because there's also the possibility that I missed one little change somewhere that is having, like this one, that was having a huge impact. That's image view, player counts. There's nothing in texture. Scene only had the shadow map cascade counts. These are all new things. I can just make sure that my shadow renderer has everything is used. It accidentally not used something up here. It looks like it's being used. Details. Suppose I could try and just to rule this out, I could try and compare those two files, although it's not gonna, I have a feeling they're not going to compare that well. Yeah, I see something here. Copy that. I'll just put it in a different folder here just for sake of argument. I'll do compare with, nope, that's not Fairytales, and then this one, and that one selected. Compare files. Okay, mine is on the left. Theirs on the right. So lights length, directory light, directional light. I'm just getting a stream of everything that is a directional light, which is just the one light. If that's no, directional light position, scene, get Z near, get Z far. Those are the same. Cascade data. Math pal. I mean, the math is still the same. Like the variables are named differently, and there's different capitalizations in the stuff, but it's still the same relatively. Corners. Wait. Wait. Oh, yeah, that's taken care of. But wait. Yeah, no, that's taken care of on any other thing. So it's just variables there. Split distance. Get the center. I mean, this should be, the length should be 8. I mean, I know they had 8.0 here, but so wait, sphere radius, float, 16 divided by 16, okay. Let's see, I did do negate there on the min extents, rather than multiply by -1, but I mean, it should be the same thing, but maybe I will change that just to be certain. I mean, my math is decent, but, you know, still be really far off on things. Show map size 1 by 2 0 30 31 32 33. Split distance times -1 matrix. Cascade splits I. Okay, I mean, everything's the same. Maybe I'll change that negate to -1. Maybe it does have an effect, a different effect than I'm expecting. Let's do that. Let's just see if that had any effect on it. Nah, it's still very jagged there. When I'm looking at it. So that was not a thing that was needed. So okay. I wonder if where's my FXAA? Why is that not found? FXAA? Why does this not find anything anymore here? I know it's in here somewhere. Look at my post-processing renderer. There we go. Somehow that got changed over. Enable FXAA is true. That's in there, so I mean it should be on. I wonder if Copilot has a suggestion on how to debug this. When it's like, what's that, Sonny? What did you ask me? Cascade shadows have jagged edges, but FXAA post-processing is on. How do I go about troubleshooting the issue? Confirm FXAA actually runs after the final composite. Shadows plus lighting plus tone mapping. Capture and compare the pre-FXAA and post-FXAA full screen images. Verify the shader sees the specialization constant in GLSL. Confirm layout. Constant ID 0. Enable FXAA. Matches your constant ID and value sent at the pipeline. Creation, I mean... the 0th one here. So I'm just putting that into the data, into the buffer directly without anything else. So I feel like that's correct. Check color space and tone mapping. FXAA expects linear RGB input or consistent space. Mismatches can make edges look wrong. Yeah. Expect shadows, sampling, filtering. Jagged cascade edges often come from low shadow map resolution or insufficient filtering. Try higher shadow map resolution. Maybe there's something there. Ensure FXAA has access to correct inputs. Full color buffer. Down sampled. Confirm no render order or stencil tests prevents FXAA from touching shadowed pixels. Check for resource allocator bugs. Corrupted. Low shadow map resolution. Well, I mean, my shadow map resolution is 2048 by 2048, which is what the book is using. Kind of don't think that would be it. We got 9 usages here. Yeah, width and height is always being set this shadow map size. Alright, so that's the render info, that's the color. Attachment info and the depth attachment. Which is what they're doing. Huh. Let's see. I wonder if I missed something with the depth attachment or something. No. That with the color attachment info. Nothing there. Color attachments. So even for the attachment, I made the width and the height shadow map size by shadow map size, so 2048 by 2048. So it should be correct. It's R32G32 S float. Right, so yeah, 103 and 3. Okay, so I have the right number there. Image usage, color attachment bits. Shadow map size is 2048. Yeah, okay. Just making sure. Image usage, color attachment bits. Shadow map cascade counts. Which is 3 for them. Should be 3 for me. It is. And then render info. $48 for the extent. So init render info. That was mine. So they have create render info. Extent, width, and height. So I did extent and width and height. Render area is got the extent. Render area, layer count is seen, shadow map cascade counts, color attachment is color attachment, or depth attachment. Info, that, result. Yeah, that's weird. That's weird. I wonder what I've done that's made that off like that. Huh. I can't be. I really that. Let's see something. Let's run mine. Tilt it down this way. I'll take a screenshot. We'll copy that clipboard and let's do GIMP there. File. Can I just like file new? 2048 by no 2560. That's what it is. 2560 by 1440. Edit paste in place. No. Not gonna let me do that, huh? Where's my... Copy that again. There it is. Alright, so I see all the jagged edges there, right? So then, let's do image. I can paste as a... This is a new layer, isn't there? Let's do a new layer. Okay. That's the active layer. So then we go over to... Close that out. Over here, do this. Tilt it down. That way. And take a screenshot, copy it. Just as a single layer. Okay. Oh, am I just tripping balls here? Are they actually identical? No, I think I pasted over what was there. Edit, paste as new image. Okay. Yeah, mine is definitely more jagged than this is theirs. This is mine. This is theirs. This is mine. Yeah, something is up where it's like definitely more harsh. Huh. Like you can see how perfectly round these are. Right, the light coming off of the hanging pots there. Whereas you look at that in mine, you can see how jagged it is. Is there... I wonder if... So when I do the post-processing renderer, this takes the source attachments. Well, let's look at the render. Wait, first of all, let's look at where we define it. It takes the lighting renderer, get attachment color. I wonder if they added something here. So, hosts render. So it takes light render, get attachment, which is attachment color. And I do lighting render, get attachment color, which is attachment color. So that's the same. List of attachments. Wait a minute. List of attachments. That doesn't come into play until we're down here. That's resize though. Shadow attachment. Okay. Cascade shadows. Attachment color. So update scene info. I believe you've got something new, right? Update scene info. Update scene info has camera, ambient light intensity, color, number of lights, and then view matrix. And I've got camera, ambient light intensity, light color, number of lights, and then view matrix on the camera. So yeah, that's all the same as it. Vector 3 float, vector 3 int. Vector 3 float, vector 3 int. Okay. So I have all that mapped correctly. And honestly, the shadows look like they're correct. It's just they have jagged edges. Which tells me they're just not getting either the FXA is not getting applied to the shadow, or it's not getting applied at all. Which I don't see how that could be the case. But I only set it in one spot, and I set it just true. But post-processing fragment shader. We do set it to 0 in here, as is default. Cosine 0. And if it wasn't getting through, you know what? Just for my own purpose here. I'm going to set this to 1, just in case somehow that's a problem. I doubt it, but let's do that in the shader. No. Okay, so it's definitely not that, because that's like forced on now. Well, kind of forced on. I guess I could really force it on by commenting this out. Let's comment that out for a second there. Let's see what happens. No, still the same. Still the same issue. So it's not that, or at least it's not. Well, it's not the shader. Let's put it that way. It could still be like the renderer is not kicking off or something. Post-processing renderer. Render. Source attachments. Did any of this change? I don't think it did. So I looked at the diffs here. They didn't really have anything. They just changed this to a 1 because it needs to have something now. There was nothing else different here. I don't know. It's going to bug me though. I mean, we can move on to the next chapter because it's technically good enough for the moment, but I'm just kind of annoyed that it's not quite working. Wait a minute. Wait a second. Do we ever pass layers of 0 into attachments? That's the wrong one. Never pass layers 0. 1 there. I think it's all 1 down here. Yeah. Here it's 3 and 3. And there it's 1. Okay. So the array layers is up in here, right? Layer count. which is now just 1 for everything, which is what it was before. So that's fine. I wonder if anything else. So Vulkan image. Did anything else change in image here? Anything subtle? Image type 2D. Format width height depth 1. MIP levels array. Layers samples. Sample count. They never change sample count that I can tell here. That's always 1 as far as I can tell. Image layout undefined is the initial layout. Sharing mode exclusive. Image tiling optimal. And then usage. Okay. And then we've got capacity 1, stack get 0, memory usage auto, and then memory usage, and then 1.0 is the priority. You may create image. Allocation LP. Okay. Yeah, okay. All that is the same as far as I can tell. I'm passing device in here and I don't even need it. I don't need it anymore. Needed it at one point. I could clean that up at some point. But let's see. So MIP levels. They didn't change like MIP levels on me or anything, did they? MIP levels of 1. MIP levels, set MIP levels. So they've got it to 1 in attachment. Or I've got it to 1 in attachment. And they've got... Wait, where did I have it? Image data. They don't set it, but then it's defaults to 1 when you don't set it. And this is only set in one place, and that's for texture. Which I believe is where I set it as well. Yeah, math floor, log 2, math min with height +1. Yeah, all right. So that's all correct side. Yeah, I don't know. I don't know where else to look to find out why that's so harsh like that. I mean, I guess the light might be at a different angle. Like, what angle did they start their light off at? I don't think they changed it. Yeah, they start at 270. And I start at 270 as well, so I don't... So we should be looking at the exact same light angle, and then I have the exact same intensity. It's just... It's weird. Oh well. I mean, it's close enough at the moment. I don't like that the shadows are jagged like that, but it's something I can work on as we go here. And who knows, when I refactor some things, maybe it will fall out of there. Something like that. I don't know. It does bother me though. It does bother me a lot. Let's take a look at chapter 17. Let me commit the changes I made though, because we did fix that one thing. So chapter 16 fixed, sort of. Shadows still jagged. There you go. Okay. I have that out there at least. Let's close all these up so I don't get confused. And we'll move to chapter 17 here. Close that one up too. Alright, what is chapter 17? Let's close that out. I think it was back-end stuff, right? Oh no, it's animations. Oof. Okay. Skeletal animation introduction. The way a model is transformed to play, an animation is defined by its underlying skeleton. A skeleton is nothing more than a hierarchy of special points called joints. These joints are organized in a tree-like structure. A joint can have a parent and several child joints. The final position of each joint is affected by the position of their parents. For instance, think of a wrist. The position of a wrist is modified if a character moves the elbow and also if it moves the shoulder. Joints do not need to represent a physical bone or articulation. They are artifacts that allow the creatives to model animation. The models still have vertices that define different positions, but in skeletal animation, vertices are drawn based on the position of the joints they are related to and modulated by a set of weights. If we draw a model using just the vertices, without taking into consideration the joints, we would get a 3D model in what is called the bind pose. Each animation is divided into keyframes, which basically describes the transformations that should be applied to each joint. By changing those transformations, changing those keyframes a long time, we're able to animate the model. These transformations are based on 4x4 matrices, which model the displacement and rotation of each joint according to the hierarchy. Basically, each joint must accumulate the transformations defined by its appearance. Okay. The purpose of this chapter is to show an example on how this can be implemented using Vulkan with compute shaders. There's another tutorial there. Okay. Loading the models. So model data class, animate models. So we're going to have more data that we have to pull in. Animation meshes. So this will contain an entry for each mesh storing the relevant data for animated models. The data is grouped under the animation mesh data and contains two arrays that will contain the weights that will modulate the transformation applied to joints related to each vertex. Okay. Mesh data. And then they're pulling that stuff in from the model file itself. Remove the flag AI process pre-transform vertices since it will not work with animated models. Use it only for non-animated ones. Therefore, we need a new command line argument to know in advance that we'll be dealing with animated models. These are the changes in the main processing thread. Oh boy. Okay. So now I need to be able to change the flags that we're putting in there based on whether or not we're loading an animated model or not. For animated models, we use the AI process limit bone weights, which is the library's name is SIMP, so that's the AI there. Flag that limits the number of bones simultaneously affecting a single vertex to a maximum value. Well, maximum value is 4. If the model has animations, we first process bone structure through the process bones method, which returns an instance of animation mesh data. Each bone joint will have different impact on the animation based on weights. After that, we construct structure nodes. The tree-like skeleton structure, which contains transformation matrices for each of the joint bones, will allow us to calculate the animation. So bones here, AI weights, nano vertices, fixed weight lists, max weights. Okay. That says bones. Interesting. It's the bones. Field nodes tree. Versus the nodes hierarchy starting from the root node, constructing a tree of nodes. Okay. Transformation, so model processed animations. It returns a list of animation instances. For each of those animations, we construct a list of animation frames, which contain essentially a list of the transformation matrices applied to each of the bones that compose the model. For each of the animations, we calculate the maximum number of frames by calling the method calculate animation max frames. Each node animation instance defines some transformation to be applied to the node in the model for a specific frame. Okay. Over different frames of build. So this is just building the, this is just reading the animation stuff out of the object file, the 3D object model file. and building it up into a structure that I assume we're then going to write to one of those JSON files to be able to read it, to be able to read into our engine. So there's a whole bunch of just like setup, first of all. Two new methods. And we have a new property called max joints. Max joint matrices lists 100. Okay. Entity, create a new class called entity animation to control the animation state of animated entities in order to pause or resume the animation. To select the proper animation and to select a specific keyframe. Okay. Okay. We will modify the entity class so it can have a reference to the animation class for animated entities. Yeah, so we're adding it to... We have a base entity and then we have the animation class for that entity. Okay. All this needs to be handled in the Vulkan model class so it can be loaded into the GPU. The changes in this class are defined. Vulkan animation. Cleanup. Has animations, okay. Vulkan mesh needs to be defined in order to store a buffer which will contain the weights. And then a whole bunch of stuff in the models cache where they load the model up. And then I gotta load all the animation stuff in there for the model. I feel like I'm going to have a whole lot of changes that I'm going to want to make as I go through this. I didn't like the way they were loading things in the first place, and now they're expanding upon that. So it has animations. We need to create the buffers that will hold the matrices for the joint and bones for each frame. Also need to store also the weight buffers. Okay. Create weight buffers. Create versus buffers. This will be accessing the contents of the versus buffer in the compute shader through storage buffers. Okay. New method to access the models map. Mesh, create a new class called animations cache that will create those buffers for all the animated entities. Then compute shader. Prior to jumping into code, it's necessary to briefly describe compute shaders. Compute shaders are a bit different than vertex or fragment shaders. Vertex and fragment shaders have a well-defined input and output. For example, when we create a graphics pipeline, we define the structure of the input data for the vertex shader. In addition to that, vertex shaders get involved automatically as many times as required to consume the input. In our examples up to this point, vertex input contains vertex position, texture coordinates, and the normals data. Compute shaders operate differently. They work over buffers as a whole. It is up to us to decide how it will execute and how they will operate over the data they will require to perform their computation, and where the results should be stored. Compute shaders access data for reading and writing through storage buffers. In our case, we will store binding pose information as read-only storage buffers and will store the transform positions in a read-write storage buffer. That output buffer will later be read in the geometry phase as a regular vertex buffer. Okay. Key topic of compute shaders is how many times they should be invoked, how the workload is distributed. Compute shaders define the concept of work groups, which are a collection of shader invocations that could be executed potentially in parallel. Work groups are three-dimensional, so they will be defined by the triplet wx, wy, wz, where each of those components must be equal to or greater than 1. The compute shader will execute in total wx times wy times wz work groups. Work groups also have a size named local size. Therefore, we can define local size as another triplet, lx, ly, lz. The total number of times a compute shader will be invoked will be the product of wx times lx times wy times ly times wz times lz. The reason behind specifying these using three-dimension parameters is because some data is handled in a more convenient way using 2D or 3D dimensions. You can think of, for example, an image transformation computation. We would probably be using the data of an image pixel and their neighbor pixels. We could organize the work using 2D computation. Probably be using the data of the image pixel using 2D computation parameters. In addition to that, work done inside of a workgroup could share some variables and resources which may be required when processing 2D or 3D data. Inside the compute shader, we will have access to pre-built variables that will identify the invocation we are in, so we can properly access the data slice that we want to work with according to our needs. For support the execution of commands, I'll go through the compute pipeline. We need first to define a new class named compute pipeline to support the creation of that type of pipeline. Compute pipelines are much simpler than graphics pipelines. Graphics pipelines have a set of fixed and programmable stages, while the compute pipeline has a single programmable compute shader stage. Okay. I mean, that's a lot, but to take in. But going back to the compute pipeline constructor, we first initialize that. Okay. Create the pipeline itself. It's completed by the getter methods for each tree. The pipeline layout handles. Update the queue class to have a compute queue instead of a graph queue. Okay, yeah. That makes sense. Create a new method in the VKUtil class called memory barrier to set up memory barriers. Yeah. Instead of, because we have image barrier there now, so now it's memory barrier because it's not image or anything. Animation render. Here's the animation computation. The animation computation shader, basically. Okay. Well, if you've ever wondered why there's so many shaders in games, it's because damn near everything's a shader that needs to run through the GPU at this point. You got post-processing, you've got animations, you've got basic transformations, you've got textures, you've got texture mapping, you've got all kinds of stuff, lighting calculations, all of that. Discard the models that do not contain animations. Yeah, okay. Responsible for recording and dispatching commands that execute for the compute shader pipeline to calculate the animations. Okay. Start and finish command recording. Write the compute shader. Okay. Scene rendering. In the render method, we need to access the proper buffers for animated entities. With dedicated buffers per mesh where the model vertices will be transformed. Okay. updates on shadow rendering. We also need to update the code that renders shadow cascades. The changes are quite similar. In the geometry phase, we just need to select the buffer that holds the vertices transformed according to the data of a specific keyframe in the shadow render class. Okay. As in the scene render stage, the shaders do not need to be changed. Final updates. Is animation render class and animations cache. Okay. Load animate model in the main class. Associate, we need to load the new animate model and associate it to an entity. This will update the animation frame of each invocation of the update method. Also set spacebar to start and resume the animation. Okay. And there's our guy, who will apparently not only have a shadow, but also do some sort of animation. So, at least when you hit the spacebar, it'll do some sort of animation. So that's gonna be a thing. Currently developing a 2D game engine utilizing the standard Java SE API. Do you consider it impossible to implement 3D functionality using strictly the pure Java SE API? Let me think. Possible to implement 3D functionality using strictly the pure Java SE API. You'll only be doing software rendering at that point. Okay, Outlaw, you have a good night. I hope the meds kick in and everything works out well for you, man. I'll talk to you later. Yeah, I mean, if you want to do 3D functionality, you can do software rendering, which is the old school, like, you take care of all the rendering yourself in the CPU. But if you want to utilize the GPU, you're gonna have to pull in a low-level library, like either OpenGL, so like Joml or Jogl, I should say, or you have to pull Vulkan in. I'm sure there's bare bones Vulkan libraries. You can use LWJGL, you could use JMonkey Engine, those kinds of things. But yeah, I don't, because the problem there is, in order to gain access to the GPU, you have to have hardware access. And the JVM's not really going to give you access to that, as far as I can tell, as far as I know. Maybe there's something you can do. I mean, unless you want to write, I say that, but you know, if you want to write C code and then put a native wrapper around it for Java, then you can certainly start to take control of the hardware and stuff. But again, remember, you gotta write, like, that code has to be different for Linux versus, you know, Windows and all that stuff. So, because that's the one difficulty with Java, is that when you want to access lower level stuff, you really can't, because it's not a platform agnostic thing to do. So to do that, you're going to have to wrap a native library at some point along the way. So yeah, I mean, but like I said, you could do a pure software renderer, where you just take care of all the transformations and stuff and all the math like that. Seems like I would effectively have to use JNI and write C code myself, which sounds like I don't. Yeah, exactly. I mean, that's basically what it comes down to, right? Is like, you would, if you want to access something low level like that, you're going to have to either use a library that already exists, And like I said, you don't have to use LWJGL. You can use, like, I think Joggle is a library where it literally just wraps the OpenGL libraries with Java, so it already does the Java native interfacing there. Joel is another one for OpenAL. So those are like lower level than even like LWJGL is. I think there's one out there for Vulkan as well that I saw briefly. Yeah, but like that's basically the way that has to work, essentially. Now, I mean, you could, I don't know, I assume you could write something in like Rust even, and then have like a native wrapper around that, but I'm not sure how that works. Like Java mostly assumes you're going to do like a wrapper around C code, like C headers and stuff. And I don't know what Rust generates in regards to that. Like if it can generate C style headers and stuff that you can then use a JNI to map to. So that might be an interesting thing too. I've never dug into any of that to know what that does. So yeah, I mean, that's kind of where we're at with that, you know what I mean? Because you have to deal with hardware. That being said, you know, like, there's plenty of examples of games in the past that were just software rendering, you know, especially DOS games. They weren't visually, you know, anything close to what we have today, but I mean, they weren't bad either, you know. The old Mech Warrior games were software rendered. The Star Crusader, the old Wing Commander games, like Wing Commander 1 and 2, were all software rendering. You know, so that's, in fact, Wing Commander 3 was software rendering as well, and 4, I believe, also was. Maybe. Yeah, 4 was also, because it was a DOS-based game. Eventually, I mean, the remake of it, I think, used Direct3D. But, yeah, all those. So it's certainly possible. There's just a bit of work involved. And you're not really going to use the full power of the system per se. All the CPUs are pretty beefy nowadays too. So yeah, it really depends. The other hard part there is dealing with the canvas, because I think if you're doing swing, you're probably dealing with, at least on Windows, you're probably dealing with like GDI stuff, which is going to be slower. Because it's not, like, that stuff is kind of, it's not necessarily built for high performance rendering, because most of the time you're just rendering static buttons and you know, documents and stuff like that, where it's more of a, you're not measuring your performance in frames per second per se. That being said, I imagine there's a way you could probably do it. I've just never really dug into that to know. Does it utilize classes like JFrame or Canvas? It does not. It does not use any swing or AWT classes now. It uses GLSL, so that's a let's see if we can find that. Not GLSL. GLSW. Right. What is it called? GLSW library. This is not quite the same thing, but it's similar. So it basically uses, ironically, OpenGL just to open the window up and to deal with window event handling. And then it defers to Vulkan for pretty much everything else going on inside the window. It used to be called Glue. GLU. Or Glut. GLUT. Library. Yeah, utility toolkits. But I believe it's like OpenGL stuff to do the actual window. So like when I do, where's the, it's actually probably in, no, it's in Vulkan Engine, right? It's in the init for the window. Yeah, there's a GLFW init. And GLFW. There we go. So this supports like OpenGL and Vulkan development on desktop. It provides a simple API for creating windows, contexts, and surfaces, receiving input and events. It's written in C and supports Windows, Mac OS, Wayland, and X11. Yep, this is the library that does it. So yeah, it doesn't use any Java Swing or anything like that, because you kind of need a library like this to handle it, because it will you need something high performance that's not bogged down with any cruft. You know, so yeah, this is what it uses, glfw.org. That said, I believe, let's see if is there a Java wrapper for glfw? Yeah, here you go. glfw. So, if you wanted to, rather than use Swing or anything like that, you could fire up JGLFW, and it'll handle window management and input and stuff like that. Also will handle audio for OpenAL, which is kind of nice. But yeah, so that's a thing. This is this still is getting commits to it last year and everything, so that's good. Still support it and everything. But yeah, that's what it uses under the covers. I mean, you think about LWJGL is, it's just a it's an overarching library that just pulls in a whole bunch of other libraries underneath, and it just provides like some convenience to them. Like you've got like a memory util to help manage the creation and the malloking and freeing up of memory and stuff like that. It just kind of handles some of the orchestration, but really it's just a giant umbrella over top of all these other libraries that you just kind of pull in and work with directly. So, and I think JMonkey Engine uses a very similar technique. I think it uses JLF or GLFW under the covers as well. I haven't tried JMonkey Engine yet to see what it's like, but I don't know if they support Vulkan yet. That's the other thing. Scene graph, engine wiki. Yeah, I wonder if they have a search here somewhere. Yeah, Vulkan. Huh. JMonkey Engine Vulkan. They have experimental support for it. JME Vulkan. This project is an experiment to determine if Vulkan can be integrated in JMonkey Engine 3 with minimal changes to the engine itself. Status promising. Oh, that's hilarious. It depends on not only JMonkey Engine, but LWJGL Vulkan. And Java 17, so it's already kind of out of date. That's interesting. Yeah, so I'm thinking JMonkey Engine has not tackled Vulkan yet, from what I can tell. Seen that before, very interested in it, but I'm even more interested in learning how to build a 3D game engine. No, I get you. Trust me, I feel the same itch, honestly. And I mean, I don't what's the word I'm looking for? I don't cringe at the fact that I'm using something like LWJGL to do it. Like I too have that kind of desire to be like super low level sometimes. But for something like this, I feel like being 2 or 3 levels removed from all the nonsense doesn't really save you anything. Right? It's like I still feel like even though there's libraries under the covers that are doing a lot of calculations for me and doing a lot of orchestration of the hardware and stuff, I don't feel bad for, like, I don't feel like I'm missing out on any kind of knowledge, I guess is the best way I can put it. Right? Like, it feels like the libraries, yes, they're doing all the really hard stuff, but also what I'm doing doesn't seem easy either. So it's like I feel like I'm getting kind of the best of both worlds there, where I'm not necessarily screwing around with the lower level stuff, but I'm also not completely removed from it either, you know? And, there's the 300-pound gorilla in the room is most people who are writing game engines are not doing it in Java. They're doing it in either C or C# or something like that, or Python, or perhaps even Rust at this point. You know what I mean? So and that's because a lot of those languages have not only larger communities, but they have gaming communities, but they have larger, they have more connections with the underlying hardware to help them out a lot more. They're not as removed from, they're not as sandboxed, I guess, is what I'm getting at there. Java was really, really big on write once, run everywhere, almost to a fault, because it's like there are some low-level things that you really wish you had access to that you don't, or at least not easily, not without jumping into JNI stuff, you know. A strong desire to implement everything yourself: rendering, model loading, object management. It seems like that might be a pipe dream. Well, I mean, the model loading is something you could certainly do, right? Like, LWJGL is, like, I'm using Asimp library to load the models up because it supports so many different model formats out of the box, right? Because a lot of these 3D models, you have no idea what file format they're going to arrive in. So that kind of just takes care of the details. Unfortunately, yeah, it's written in C, so you have to use JNI to get at it, but it's like, there's nothing that says that there couldn't be a pure Java implementation of that, because you're just reading a file at the end of the day. That could certainly be a pure Java implementation, and that would be probably pretty difficult in and of itself, because again, there's so many different formats that even Blender supports, you know what I mean, if you just look at that for one thing. And there's so many different things that get stuffed into those files. The object management, I mean, I'm kind of doing that with LWJGL. Like, you're not directly putting stuff into, well, I mean, you kind of are directly putting stuff into buffers. It's just there's low-level code that you're calling out to do it. You're not writing the low-level code yourself. So I can kind of see where you're getting at there, where it's like, I want to be the one writing the actual code. I get it. And the rendering too is the same thing. It's like, yes, technically I'm handling the rendering, but I'm really just kind of handing it off to Vulkan to do it. So, but that, I get it. Like I said, if you really wanted to do the rendering and stuff, I mean, you could do software rendering. You don't have to use Vulkan for it. You can actually probably pull in the GLFW library, and then what you've got essentially is just an empty window with a canvas, and from that point on, you can probably link in right into that window and just start making your own software rendering engine for it, and then just go from there if you really want to go that path. But yeah, that's certainly a thing. So I mean, those things are doable to a certain extent. Depending on how, I mean, they're imminently doable if you want to really go ham and like start writing C code or whatever, and then use J and I to get at it. Or, you know, you can try to stay as pure-ish Java that you can get and just drop out of Java for like the very basic stuff. You know, like you don't have, like I drop out of Java a lot here for what I'm doing in LWJGL. You know, I'm doing a lot of native calls, but there's certainly a lot there that could be replaced, you know? All right, no problems. No problems whatsoever. I'm actually getting ready to call it anyway. This chapter looks pretty daunting, and I think I want to come at it with a fresh perspective tomorrow, probably off stream, and see where I end up. But yeah, no, I mean it's always good to be curious and just kind of, yeah, I get the feeling too. It's like you kind of want to just be very low level and stuff, and I get it. But I'm also kind of, I know that there's stuff down at the low level that I will not be able to process. Like I'm using a lot of libraries because I know there's a lot of stuff that I won't be able to process, just brain wise. So anyway, I think that'll be good for me for tonight. I don't know. Again, this week has been kind of weird because I've been on this kick to do coding. I've been very invested in it. So I don't know if I'm going to play a game tomorrow night. I don't know if I'm going to do more code tomorrow night. I'm just going to kind of play it by ear. Eventually, we'll get back to a regular schedule. Once I get, this is my last week of vacation. So once I get back to work next week, I'll probably be back to doing games at nighttime with just Friday and Saturday coding streams, because I'll be doing enough code during the day that I won't want to do more at nighttime probably. So we'll see. We'll see on all that. But anyway, that'll do it for me for tonight. If you happen to run across this on the YouTubes and you have a like and or subscribe that you can spare, maybe toss my way, that would be really great and awesome. It helps out tremendously, and I appreciate it greatly. Otherwise, thank you so much, everyone, for watching. I hope everyone has an excellent morning, afternoon, or evening, depending on what it is for you. I hope to see you back here again in the future for some more stuff, whatever happens to suit your fancy. Until then, see you then.
Same old story. Boy finds girl, boy loses girl, girl finds boy. Boy forgets girl, boy remembers girl. And girl dies in a tragic blimp accident over the Orange Bowl on New Year's Day.
Good year.
No, the worst.